Hi everyone again. This is going to be a little bit shorter, I hope, of a video for you for this week. This time what we're going to be talking about is balancing chemical equations. And so balancing chemical equations is an important step for our upcoming chapters on stoichiometry. And so after today, every time you see a chemical equation, number one thing you should try to do is balance it. Make sure it's balanced before you do anything else in future problems. So in general, when you look at a chemical equation, they're written so that the beginning, what you start with, are typically called reactants. And then there'll be an arrow. The arrow can be read as goes to or yields. And what you end up with are called products. So when you write a chemical equation, there are a few things that need to be told. One thing is you need to state the identity of the reactants and products. For some reactions, this will be given to you, and later in the chapter, you'll be asked to predict products for certain reactions. The second thing you'll need to be able to do is state the relative amounts. Of the reactants and products. That's what we're going to talk about today. That's what the process of doing this is called balancing. And then sometimes you'll see states of matter will be included. So in the states of matter, what you'll see is after a substance, you'll see subscripted S for solid, L for liquid, G for gas, and sometimes you'll see AQ, which means that it's aqueous or dissolved in water. So there's a difference between NaCl, that means I have white crystalline salt, or if I see NaClAQ, that means that I actually have salt water. The salt's dissolved into water. So what we're going to practice now is how to balance the equations. And when we're balancing equations, there are a couple of rules to use. So the idea is to get the same number of atoms for each element on both sides of the equation. I'm going to show you the process that's called balancing by inspection. So we're just going to look and count how many atoms of different elements are on each side and correct it. Now, when you're changing how many things you are putting on each side, what we're going to do is change coefficients. Never change the subscripts. I'll show you what I mean by that. So if we started out with a nice simple equation, something like hydrogen gas plus chlorine gas turns into hydrogen chloride gas, and I would ask you, is that equation balanced? The first thing you'd have to do is count how many atoms of each element are on each side. So on the reactant side right here, we have 2 hydrogen atoms. But on the product side right now, we only have 1 hydrogen atom. And so this equation is not balanced. Now to balance it, I need to get 2 hydrogens on my product side. I cannot do this. I can't just change it and make it be H2Cl. This is not allowed. This would be changing a subscript. The reason we cannot change a subscript is because the substance is HCl, and that if I change the subscript, then I've actually changed the identity, the formula for the product that was stated. So how do I get 2 hydrogens on the product side? I'm going to add a coefficient of 2. The number out in front is a coefficient. The number down below, this would be a subscript. And so when we're looking at equations, we're going to always change coefficients, never change subscripts in order to balance them. The other thing to notice is that a coefficient in front counts for everything after it. It's similar to if I would have put 2 with a parentheses. It's going to be 2 times whatever is inside of this parenthesis. And so now that I have a 2 in front of HCl, it also tells me that I have 2 chlorines. Now I have 2 hydrogens, and I also have 2 chlorine atoms. And if I look on this side, I also have 2 chlorine atoms. And so this equation would be balanced by putting the coefficient of 2 in front of HCl. Now, most equations are really this easy to balance, although they can get a little bit trickier. But a little more time consuming to do, but all it really takes is practice in order to do this. So let's try a couple other together and see how you do. So let's try to balance the next equation. Let's say you had hydrogen and oxygen, and we're going to turn it into water. If you wanted to balance this equation, you can just pick any element you want to start with. As a hint, try to leave oxygens to last because it just turns out to make things a little bit easier. So if I look at this one, I'm going to look on my reactant side and see that I have 2 hydrogen atoms. I'm going to look at my product side and I also have 2 hydrogen atoms. So at this point, I'm not going to add any coefficients. But if I go to my next element, oxygen, on my reactant side, I have 2 oxygen atoms. On my product side, I only have 1 oxygen atom. This equation is not balanced. Now I need to get 2 oxygen atoms on my product side. Again, I cannot do this. That is not allowed because that would not form water then. It would form hydrogen peroxide. So I need to get 2 oxygen atoms, and my only way to do that is to put a coefficient of 2 in front of the water. Now that's going to give me 2 oxygen atoms, but it's also going to mean that I now have 4 hydrogens. My oxygens are now balanced, but now my hydrogens have a problem. In order to get my hydrogens balanced, I'm going to need to up this to be 4 as well. And to get 4, I also need to add a coefficient of 2 in front of the hydrogen. Now I have a total of 2 times 2, 4 hydrogens, 1 times 2, 2 oxygens on the reactant side. On my product side, I have 2 times 2, 4 hydrogens, and 2 times 1, remember the 1's not written, although it's there, for a total of 2 oxygens. And so that would be a balanced equation. Another example would be if we were trying to do, let's say, a combustion reaction. And so if I tried to do a combustion reaction and I told you we had a compound C2H6 and we were going to burn it in the presence of oxygen and create carbon dioxide and water, and I asked you to look at this equation and balance it. If we were going through balancing, same thing by inspection, just pick your first element and go ahead and try to balance it. So on this side right now I have 1 carbon atom. On this, oh sorry, I have 2 carbon atoms. And on this side I have 1 carbon atom. And so to get 2 carbon atoms, I'm going to put a coefficient of 2 in front. Just because I put that there doesn't necessarily mean that's going to be my final answer. I'm going to keep going with my next element. I have 6 hydrogen atoms. And on this side right now, I only have 2 hydrogen atoms. So I'm going to put a coefficient of 3 in order to make this become 6. So now I have my carbons balanced and my hydrogens balanced. So let's try on oxygens. On my reactant side right now, I have 2 oxygen atoms. On my product side over here, I have 4 oxygen atoms plus 3 oxygen atoms for a total of 7. Now the problem is I have 2 on this side and I have 7 on that side. I need to get the same amount. So what do I have to multiply 2 by to get to 7? Well, 2 times 3.5 is equal to 7. So I could put a coefficient of 3.5 in here. However, if I was reading this equation in terms of molecules, I could never have a half a molecule. So when we do this, we need our coefficients to be whole numbers. So I'm writing that down. Need coefficients to be whole numbers. So my ratio is now good. This is just like empirical formulas. Remember, you need to get the lowest whole number ratio. And in coefficients, we also need a whole number ratio. So how do I get 3.5 to be a whole number? Whenever I have anything 1/2 and I want to get it to be a whole number, I could multiply it by 2. So now if I multiply 3.5 by 2, I would get 7. But remember, if I do that to 1, I have to do it to them all. So now I'm going to need 2 here. This is going to become 4, and this is going to become 6. And my final balanced equation will be C2H6, 2 of them, plus 7O2, 4CO2, plus 6H2O. And we can verify that we have everything correct. If we look here, we have 4 carbon. If we look here, we have 4 carbon. If we look here, we have 12 hydrogen. If we look here, 12 hydrogen. Here we have 14 oxygen, and over here we have 8 oxygen, and over here we have 6 oxygens for a total of 14. So our equation is balanced. I put a link to some practice problems, and there's 3 different levels: simple, intermediate, and advanced. And you can say how many of them you want to do, but there's tons of practice there, and it will tell you right away if you're correct or not. You can also try the ones in the homework that have been assigned in the textbook. This is the beginning of chapter 7 in your book. So I hope you have an easy time balancing equations, and we'll see how you do. I'm going to post a quiz or some other practice for you on Canvas later in the week. Have a good one. Stay safe.